So in this question, I've got the definition of a parametric curve is x equals 4 sine t and y equals sine of 2t. And I want to find the indefinite integral to represent the area under this parametric curve. So my basic integral setup for this is the integral of y dx. Now dx is with respect to t. So what I would do first is do the derivative of x equals 4 sine t. So therefore dx 4 sine t, derivative of that, straightforward, just 4 cosine t. And that's dt. So now I've got a definition of my dx with respect to t. And my y is already with respect to t. So now these are my building blocks to set up my integral definition. So the integral of y, so sine 2t. So just put a bracket around that for the input of the function. 4 cosine t. So times 4 cosine of t dt. Now two things I spot here. First of all, this 4 can come out to the front, but my inputs for my trig functions are different. I've got 2t and a t. So I want to do something probably with this 2t here. So sine of 2t, let's just have a look at that. What is that equivalent to? Well, I've got my trigonometric angle sum formula. So I've got sine of a plus b. That equals sine a cosine b plus sine b cosine a. Now here, because I've got 2t, if I let a equal t and let b equal t, I've got t plus t, so sine of t plus t. So we can see clearly that's going to be 2t. And then I've got sine t cosine t. And then b and a are the same again. So now I've got sine t cosine t. Okay, just simplify this off a little bit. So now I've got sine of 2t is equal, well they're the same, so I've got two of them. So I've got 2 sine t cosine t. So I've got a definition for sine 2t, which I can just plug into here. So let's do that. So I've got a 2 there, which I'll bring out to the front. And then I've got sine t cosine t. And then I've got 4 cosine t, so bring the 4 out the front as well. So these have to be multiplied. Put my other cosine t in there. And then dt. So now everything's in terms of t. I've just got rid of my brackets. Hopefully that's okay for you. So now to rewrite this, I've got 8 sine t cosine squared t, because I've got 2 cosines, and dt. Okay. Now to integrate this, what I would do is here, if I've got a derivative of this, which can cancel out this, then I'm onto a winner. So if I let u equal cosine t, so this is going to be different to all of that, as is that, as is that. Let's keep them separate. So u equal cosine t. So therefore du, derivative of cosine is negative sine. So negative sine t dt. So do that. I can plug into here and get this in terms of u. So now I've got 8 times sine of t. I'm just going to put that in for now. So I know I want to get rid of this sine of t, so I'm going to put that in a bracket. Cosine squared t is just u squared. And then dt, well, dt isolated would give me dt equals du over negative sine t. So let's just put that into there. So dt is that, which is that. So then du over negative sine t. Now good things happen because these two signs will cancel out, and I've got a minus here, which I can bring to the front. So let's just simplify that off a little bit. So I've got minus 8, the integral. Sines cancel, so I've just got u squared, and then du. Now I've got a nice integral, u squared, increase the power by 1, divide by the new power. So this would just be minus 8 u cubed over 3. Okay, now what is u? So I want to get back in terms of some sort of trig functions defined in the variable t. U is cosine t. So let's just change that u for cosine t. So I've got minus 8 cosine cubed t all over 3. And not forgetting plus c. And that would take care of that. That's my indefinite integral for this parametric curve. Okay,